Welcome to the video lecture series on formal languages and automata theory. In today's video lecture, we'll be learning about Chomsky hierarchy of languages. So this is the most significant topic in formal languages and automata theory subject, or otherwise it is called as theory of computation. So now first we will learn about what is meant by a grammar. So grammar is a set of rules which actually determine the pattern of a language. Now, this grammar is actually composed of four different concepts here: V, T, P, and S. V is called as a set of non-terminals, T is set of terminals, P is productions, and S is called as a starting symbol. So, when all these four components club together, then it's actually frames a grammar here. Now, we will learn about this individual constituent parts one by one. Now, first, what is meant by non-terminal? So that is called as V here. A non-terminal, any uppercase alphabets is called as non-terminals. For instance, we have here A, Z, D. So we can see that A, Z, and D are all alphabets, and this is in the capital case letters. So any alphabets which is in an uppercase letter is called as non-terminals. Now, we will jump to the next concept called as terminals. So, what is terminals? Any small case alphabets or any numbers or any special symbols are called as terminals here. So, terminals can be denoted by T, and these are the examples for terminals. I have given here A, B, 1, 0, plus and slash. So, all these special symbols also are also part of terminals here. Now, the next topic is productions. So, set of rules associated in generating a language is called as productions. So, production is generally, it takes a form alpha tends to beta. Now, what is this alpha and what is this beta? So, alpha and beta are actually association of terminals and non-terminals any number of times. When I put a star on the top, you can see that it is called as a combination of terminals and non-terminals any number of times. Star means it is called as 0 or more number of times. That is the meaning of it. So, V is called as set of non-terminals, T is called as terminals, and U is actually a union operator. So, when you club terminals and non-terminals together, then it is called as, it actually generates alpha and beta here. Now, an example for production is, you can see S, A, small a, capital A, as on the left side tends to D, small b, and capital D again. Now, this is actually called as a production. Now, we will go for the next one called a starting symbol. So, starting symbol is actually, it's a non-terminal itself. Starting symbol itself is a non-terminal. And how will you identify a starting symbol? So, if you have n number of productions, you take the first production, and if you see any non-terminal on the left side of the production, then that is called as a starting symbol. For instance, in this case, I have two productions. A tends to be BA and B tends to BC. Now, what is the first production? A tends to BA is called as the first production. Now, take the first production, go to the left side. When you go to the left side of the production, you can see A. Okay. So, A is called as the starting symbol in this case. So, now we will go and learn about the hierarchy of languages. So, there are four types of languages here. So, type 0 or unrestricted grammar, type 1 or context sensitive grammar, type 2 or context free grammar, and type 3 is called as a regular grammar. Now, pictorial representation which is given on the right side in the form of circles. So, the most restricted grammar is type 3. So, next restricted grammar is type 2, and the next level is type 1. The most grammar which without any restrictions is called as type 0. So, now we will learn one by one about this grammars here. Now, what is type 0 grammar? Type 0 grammar is also called as unrestricted grammar, or otherwise it is called as phrase structured grammar. So, the language which is generated by this grammar is called as unrestricted language. So, when you use a grammar is actually used to generate the patterns in a language. So, the mathematical model which actually accepts this unrestricted language is called as Turing machine. So, the most powerful mathematical model in formal languages and automata theory is actually Turing machine. So now, how come this type 0 grammar? What is the form of this type 0 grammar? Type 0 grammar takes a form alpha tends to beta. Now, what is this alpha and beta? We have learned in the previous concepts. Alpha and beta is actually a combination of non-terminals and terminals put together. But understand that alpha should have at least one terminal, one non-terminal on the left side. One non-terminal on the left side. Okay. Now, I have given a specific example here for type 0 grammar. SDA tends to FB. Okay, you can see that you have terminals or non-terminals on both the left side and right side here. So this is called as a grammar which is associated with the type 0 or unrestricted grammar. The next is type 1 grammar. So what is type 1 grammar? Type 1 grammar is also called as context sensitive grammar. So the language which is created by this grammar is called as context sensitive language. So the model which accepts this context sensitive grammar is called as a linear bounded automata. Now, what is the form of this grammar? So again, it takes the same form, alpha tends to beta, but understand that the length of alpha should always be less than or equal to length of beta. And alpha and beta should be always associated with non-terminals and terminals put together. So you should understand that alpha should have at least one non-terminal on the left side. Now I have given a grammar here, AB, and AB tends to ABC. You can see that the left side length is actually 2. You have only 2 parts on the left side. On the right side, you can see that are 3 parts. ABC, there are 3 parts here. So left side length is 2, and right side length is 3. So left is less than right here. So obviously this is called as type 1 grammar. Now we'll go for type 2 grammar. So type 2 grammar is also called as context free grammar. The language which is created by this grammar is called as context free language. Now the model which is accepting this context free grammar or for context free language is called as push down automata. So the general form of this context free grammar is alpha tends to beta, but understand that alpha should have only one non-terminal on the left side, and beta can have a combinations of terminals or non-terminals any number of times. So alpha should have only one non-terminal on the left side. So the classic example for this is A tends to BCD. You can see that in this grammar you have only one non-terminal on the left side. On the right side you can have terminals and non-terminals put together any number of times. So this is an example for type 2 grammar or context free grammar. And we come to the end of the session. It's called as type 3 grammar. Type 3 grammar is also called as regular grammar. The grammar which is used to, the language which is generated from this grammar is called as regular language. The model which accepts this regular language is called as finite automata. So the grammar takes a form alpha tends to beta, but understand that alpha should belong to only one non-terminal, and when you come to beta on the right side, it should be followed by a terminal, should be followed by a non-terminal, or otherwise a non-terminal can be followed by one terminal. So one non-terminal and one terminal. One non-terminal, one terminal can be on the right side, and we can also have only one terminal on the right side. Okay, so you can see that in this case I have A to small a. A is called as a non-terminal on the left side. Right side you can have only one terminal. Yes, that is accepted here. We have only small a on the right side. And the second example, B is a non-terminal. On the right side you can have terminal B and followed by a non-terminal called as D. So this is called as right linear grammar. Okay, right linear grammar. But this can also be done in the form of left linear grammar. Left linear grammar means in the left side you can have a non-terminal. So B tends to capital D, B. Okay, a terminal is following a non-terminal. So this is also called as a type 3 grammar or regular grammar. So that's all about hierarchy of languages. So thanks for watching the video. Have a good day.